Now this illustration deals with overcurrent protection for a commercial AC transformer and DC rectifier arc welder in accordance with NEC 630.12a. Now in the NEC loop, if we want a little bit more information, we refer you to our figure 9-11, which deals with overcurrent protection for electrical equipment, motors, etc., and air conditioners and all that. But notice in the overcurrent device, starting with it again, 200% of the full load amps in accordance with 240.4G as well as table 240.4G, and it all starts in 630.12a and b. Now notice if you don't want to use the quick calc 2 completely, you can go to quick calc 1, and if the duty cycle on the welder said was 80%, take the square root of it, and that's your multiplier, 0.89 or 89%. Now, sizing the conductors in accordance with 630.11a and table 630.11a, we would take 85 amps, which is the the nameplate full load current, as you see below the duty cycle, 80%, pointing the arrow to the welder to the left, right next to the figure loop, if you want to look at it. 89% of 85 is 75.7. Now, applying table 310.16, 75.7 amps requires a number 4 conductor. Now, applying the overcurrent device sizing in accordance with 630.12b as in boy, the number 4 conductor has an ampacity of 85 amps. So we take the 200% from our 630.12a, I believe it is, and we take 200% of that conductor's ampacity, which would be 170 amp. And we'd round that down to 150 if we wanted to, and that would let that welder weld and operate on an 80% duty cycle. Now the question always comes up, could I go lower? Sure. You can go lower as long as it will perform with the type of welding job you're doing. But if it won't, you're allowed to go on up to a 150 amp overcurrent device on number 4 wire, because table 240.4G says the overcurrent device can be greater than the sizing of the conductor. So this illustration in figure 14-33 is illustrating this concept of design and installation.